The perspective camera model is probably the most popular one used in computer graphics. Due to its simplicity and computational efficiency, it is used in tools such as OpenGL and DirectX. One of the perspective camera's features is the ability to show straight 3D lines as straight 2D lines in the camera image. This feature can be seen when looking at the 3D checkerboard pattern being transformed into an image. Another feature includes changeability of angles between lines. They are not constant. They change depending on the relative position of 3D lines and the camera. That means that parallel lines in 3D will not stay parallel in 2D. This effect is greater for wider fields of view, and it's almost not visible if the field of view is very narrow. The perspective camera model's theoretical field of view stretches between 0 and 180 degrees, but for numerical reasons the field of view must remain above 0 and below 180 degrees. When the field of view is narrow, the image is zoomed in. When the field of view is wide, the image is zoomed out. As the camera's field of view gets wider, you can notice the image getting more and more distorted on the edges. The image on the edges looks stretched. In practice, when using a perspective camera, the field of view is mostly between 10 and 120 degrees. For reference, the central field of view of the human eye is around 50 degrees. In Xylon surround view, it is usually between 50 and 120 degrees. A camera with a field of view up to 120 degrees will satisfy most of the demands. In case you need a wider field of view, it is advisable to use a different camera model, such as a spherical or cylindrical model. If you need a field of view wider than 180 degrees, then some other model must be used due to the perspective model's limitations. In Xylon's logiVIEW IP core for AMD programmable devices, the perspective camera model is the standard and computationally most efficient camera model. Let's look at several use cases for the perspective camera model. The multi-camera view is used to stitch images from multiple cameras into one seamless panoramic image. Using the virtual camera, the user can choose which part of this panorama is going to be shown. The user can also choose the type of camera that will be used to get this image. A virtual camera can be placed and rotated anywhere in the coordinate system. Intrinsic camera parameters, such as the field of view, can be changed. The perspective camera model can also be used in Xylon's single camera view. The single camera view can transform images between any two camera models. Besides perspective, it also supports spherical, cylindrical, and real camera models. Unlike with the multi-camera view, in the single camera view, the destination camera must be at the same position as the source camera. Here you can see the transformation of the image taken from the real camera to the perspective camera image. The perspective camera model is radially symmetrical, which means that it can be used for image transformation with the logiVIEW IP core's lens correction module. The same applies to other radially symmetrical camera models, such as the spherical and real camera models. With the logiVIEW lens correction, it's possible to transform the image between any radially symmetrical models. Here you can see how the original image taken with a real camera is transformed to a perspective camera model. Thank you for watching.